Using Cayley-Hamilton theorem, find the inverse of matrix A. Matrix A is given 2 cross 2, 2, 3, 3, 5. So, using Cayley-Hamilton theorem and find inverse of matrix. Okay, the first is the characteristic equation is determinant of A minus lambda I equal to 0. Take determinant 2 minus lambda 3, 3, 5 minus lambda equal to 0. Okay, expanding, simple technique, expanding, multiplication 2 minus lambda into 5 minus lambda minus 3 into 3 is 9 equal to 0. Open this bracket, we get lambda square minus 7 lambda plus 1 equal to 0. Okay, by Cayley-Hamilton theorem, put lambda is equal to A. So we get, put lambda is equal to A means A square minus 7A plus 1 means is a I or 1 as it is equal to 0. Now we required inverse of matrix. Multiply by A inverse. We get multiply by A inverse, inverse of A square minus 7 inverse of A into A plus 1 into A inverse equal to 0. Now see, this is A raised to minus 1, this is A square, so after remaining A only, and minus 7 A raised to 1 and A means it is A raised to plus 1. So required inverse of A means this part. Therefore inverse of A is equal to now is this step is, since inverse of A and A is a I. Now this one is shift right hand side is a minus sign and this one is shift right hand side plus 7I, and inverse of minus 1 A square is a 1, so minus A. These two shift right hand side, the sign is changed, minus to plus, plus to minus. Therefore inverse of A is equal to 7 into I means unit matrix, order is 2 cross 2, 1 0 0 1, minus A is a given matrix 2 3 3 5. Okay, now this is equal to multiplication 7 0 0 7 and second one is as it is 3 5. Now therefore inverse of A is equal to 7 minus 2 is a 5, then minus 3, and third one is minus 3, 7 minus 5 is a 2. This is a required inverse of A. Okay, next example. Next example is find inverse of A. If A is given 2 minus 3, 7 minus 4 using Cayley-Hamilton theorem. The characteristic equation is determinant of A minus lambda equal to 0. So write in a determinant, take lambda minus lambda diagonally, 2 minus lambda minus 3, 7, 4 minus lambda equal to 0, and this one you expand it. Expanding 2 minus lambda into multiplication minus 4 minus lambda, then minus sign, 3 into minus 3 is 7 into minus 3 is minus 21 means plus 21 equal to 0. Open the bracket, we get lambda square plus 2 lambda plus 13 equal to 0. By Cayley-Hamilton theorem, put lambda is a. Now therefore A square plus 2A plus 13 equal to 0. Okay, next step is multiply. Multiply by inverse of A. So we get, so multiply inverse into A square plus 2A into A inverse plus 13 A inverse equal to 0. Okay, now we required inverse of A. Therefore 13 A inverse is equal to, these two terms shift right hand side, but is a first you see A raised to minus 1 A square, after you get A only, you shift right hand side is a minus A, this is also minus sign, and this one is A into inverse of A is a I, shift right hand side minus I. Okay, now 13A inverse is equal to, write matrix A minus of 2 minus 3 7 minus 4 minus 2 into I, unit matrix. Now this is equal to, take minus outside inside, minus 2 plus 3 minus 7 plus 4, then minus 2 0 0 2. Now subtraction, so you get 13 A inverse is equal to minus 4 3 minus 7 4 minus 2 is a 2 only. First one first, second one second, first one first, second one second, subtract it. Okay, therefore A inverse is equal to, 30 is cross multiply, 1 by 13 into matrix minus 4 3 minus 7 2. This is a required inverse of A. Use Cayley-Hamilton theorem to find inverse of A. If A is given square matrix 3 cross 3 1 1 3 1 3 minus 3 minus 2 minus 4 minus 6. Okay, now first the characteristic equation is determinant of A minus lambda equal to 0. Take a determinant, take minus lambda diagonally, 1 minus lambda 1 3 1 3 minus lambda minus 3 minus 2 minus 4 minus lambda equal to 0. Now expanding, so expand this one, determinant. First one is 1 minus lambda, take 4 elements, multiplication 3 minus lambda into minus 4 minus lambda, minus sign, minus minus, again 3 times minus, minus is as it is 12, minus 1 first element, then after second one minus 1 into, take these 4 elements, multiplication minus 4 minus lambda and minus minus again minus 6 plus 3 plus minus plus 3, take these 4 elements, multiplication minus 4 minus sign, this minus is plus, 2 into 3 minus lambda. Simplifying this one, we get lambda cube minus 20 lambda plus 8 is equal to 0. By Cayley-Hamilton theorem, put lambda is equal to A. Therefore A cube minus 20A plus 8 equal to 0. Then after multiplying, multiply by A inverse. So we get inverse of A into A cube minus 20 into inverse of A into A plus 8 inverse equal to 0. Now this is a square minus this one is 20I plus 8 inverse equal to 0. Okay, now required only inverse of A, means these two shift right hand side. 8 inverse of A equal to, it is a square minus a square plus 20i, or 20i minus a square is equal to 8a inverse. Now therefore 8a inverse is equal to, now see, 20i, I is a unit matrix, order is 3 cross 3, 1 0 0 0 1 0 0 0 1, minus a square, a is given 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4 into again a 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4 is equal to 20. Multiply each one, 20 0 0 0 20 0 0 0 20, first one, minus matrix multiplication. So matrix multiplication you get after multiplication is minus 4 minus 8 minus 12, after multiplication minus 2 22 6 2 2 22. Now this is equal to, again subtract this matrix minus this one, we get is a 4 24 plus 24, and it is a 4 6, sorry, is a multiplication, so minus 8 plus 8, and this is a minus 12 plus 12, sorry, this is 12, and plus 2 minus 2, and minus 6, first one minus 2 and minus 2, and it is a 20 minus 2. So 8a inverse. Now therefore inverse of a is equal to, so inverse of a, so 1 by 8 multiply is a 24 8 12 2 minus 2 minus 6 minus 2 minus 2 minus 2. Now each row you take 2 common, each row you take 2 common, take 2 outside, 2 by 8 is a 1 by 4. Now inside is a 2 outside is a 12 8 6 1 minus 1 minus 3 minus 1 minus 1 minus 1. This is the inverse of A. Okay. Next example is, next one, find A inverse if A is given 1 0 3 2 1 minus 1 2 minus 1 1. Okay, given, find inverse of matrix. The characteristic equation is determinant of a minus lambda I equal to 0 minus lambda take diagonally is 1 minus lambda 0 3 2 1 minus lambda minus 1 2 minus 1 1 minus lambda equal to 0. Now expanding this one, so expanding 1 minus lambda multiplication, 1 minus lambda into 1 minus lambda minus sign 1, again 3 times minus 1, 0 into anything 0, this second term is a 0, no problem, minus 0, then third one is plus 3, these 4 elements minus 2 and minus 2 into 1 minus lambda equal to 0. Therefore simplify this one, we get lambda cube minus 3 lambda square minus lambda plus 9 equal to 0. By Cayley-Hamilton theorem, put lambda is equal to a. Therefore this is a cube minus 3a square minus a plus 9 equal to 0, and multiply by inverse of a. Each term we get 0, but since a inverse into a equal to I, this one, now required a inverse only, this part is required, 9a inverse equal to, shift right hand side, this is a negative, this is positive, this is positive, after the shifting. So first is write minus, write first positive, this one, shift right hand side, this is I, this part is I, minus I means is a plus I, and minus raised to minus 1 square, square is 1 is remaining, a is remaining, minus 3a shift plus 3a, and a raised to minus 1 a cube, a square, so shift minus a square. Now this is equal to, I means unit matrix 1 0 0 0 1 0 0 0 1 plus 3 into I 3 into a is a given matrix 1 0 3 2 1 minus 1 2 minus 1 1 minus a square means multiplication 1 0 3 2 1 minus 1 2 minus 1 1 into one more a 1 0 3 2 1 minus 1 2 minus 1 1. Okay, now this is equal to unit matrix as it is. So 3 multiply each element, plus 3 is 3 0 9 6 3 minus 3 and 6 minus 3 3 minus sign. So after multiplication, row into column, row into column, row into column, first row, second row into first, second, third, second row, third row, first, second, third column, third row. Now after multiplication you get this matrix, these two matrix, multiplication 4 minus 3 6 3 2 4 0 minus 2 5. After multiplication you get like this. Again these two addition, this is 4 0 9 6 4 minus 3 6 minus 3 plus 4, addition of two matrices, and this one is as it is 4 minus 3 6 3 2 4 0 minus 2 5. Okay, this is a 9a inverse. So after subtraction, this minus this matrix minus this matrix, after subtraction we get is 4 minus 4 0 0 minus 3 plus 3 9 minus 6 3 sorry plus 6 sorry 9 minus 6 is 3 sorry 3, and 6 minus 3 again 3, 4 minus 2 sorry 4, the minus 2 is a 2 only, and minus 3 minus 4 minus 7, 6 minus 0 6, minus 3 minus of minus 2 is a minus 1, 4 minus 5 is again minus 1. Okay, therefore inverse of A, 9 is cross multiplied, means 1 by 9. So 1 by 9 is equal to 0, 3, 3, again 3, 2, minus 7, 6, minus 1, minus 1. So this is a required inverse of matrix.